Okay, this is problem number 2 on quiz 3 of the blue form. Alright, so I want to estimate the instantaneous rate of change of this function, negative x squared plus 2x minus 1, at x equals 2. Okay, so first things first, I want to know is the instantaneous rate of change. So instantaneous rate of change, well, that's the derivative at the point. But I only want to estimate it. So I gave a point for recognizing that this means the derivative, but we want to use some kind of approximation technique here. Okay, so the derivative is this guy, is f of x h, but it's this guy when you make h really, really, really small and get really close to 0. So if I want to approximate it, I'm just going to plug in an h really small. In this case, my x is 0. So x equals 2, h equals, let's say, 0.0001. Okay. Now, plug this in, we're going to get, so f of 2 plus 0.0001 minus f of 2 all over 0.0001. Okay. Well, this will be 2.0001 squared, then make it negative, plus 2 times 2.0001 minus 1. Okay. Then from that we're going to subtract f of 2, so we'll have negative, so it'll just be 2 squared plus 2 times 2 minus 1. Or we could have looked up here and recognized that we already found this in part 1. F of 2 is just negative 1. Right. So I could have just put negative 1 here, so it would be this whole thing plus 1. Either way, you plug this in, and you plug it into your calculator very carefully, you should get something that's about negative 2. I think it came out to like negative 2.0001, or it might have been negative 1.9999. I forgot which it was for this one. But either way, something right next to negative 2. So that's our answer here. Or, there's another method you could use, f of x plus h minus f of x minus h over 2h. This is another estimation formula. So if we just took, let's say, again, add 0.0001 to 2, you end up with this. And if you plug this in your calculator, you plug in 2.0001 just like you did up here. Then you're going to have to plug in 1.9999 over here. And then you divide it by, this will be 0.0002 instead of 0.0001. Plug this into your calculator and you should get something even closer to negative 2. So this should give you about the same answer. I think it's easier to remember this one because this is what we use for the derivative. Just know that this one exists and it actually comes a lot closer to the correct derivative.